For those who haven't heard it, how many of y'all are actually developers over here? Okay, website developers, web apps, mobile apps. Cool, no worries. So this basically is going to be a little advanced topic. It's a niche field. Not a lot of people are doing this, okay? But what I'll be doing is I'll be covering this from the very basics, okay? From very basics. It's going to be fun, interactive session. I'll show you a couple of demos as well. What I want you to show, what I want you to learn, all of them, I'll be showing it over here. Let's start. So my name is Vaibhav. I have around like 3+ years of experience into this field of cybersecurity. Done a few certifications, and I'm an organizer at Hack the Box Mumbai Meetup. How many of you all know about Hack the Box? A lot of you all, right? Okay, so Hack the Box runs a community, small meetup groups. I'm from Mumbai, so that's where I lead Hack the Box Mumbai Meetup. So that's a little bit about me. So before moving ahead, we are going to learn some little demonstration of iOS pen testing. Any iPhone users in the house? Oh, very less of y'all. The rest are Android, right? Anyone who uses a Windows phone? No. Okay. Do you guys know what is the extension for an iOS device? Sorry, an iOS application. Nope. .ipa. Okay. For Android, .apk, right? What is this .apk and what is this .ipa? Any idea? What files? What type of files are there? Okay. So what's an exe? Executables. What is there inside an exe that makes it executable? That you can run programs. What is there inside that exe? Ever thought of it? Ever questioned? So as engineers, as cybersecurity experts, the first and foremost thing that you should be doing is to question each and everything that you see, okay? The technology stack is not built just like that. There are a lot of things that are going on at the back end. You should be knowing all of those stuff, okay? So what I'm going to do is I'm going to introduce you to what and how a basic iOS structure looks like, a basic IPA file looks like. And I'm not going to tell you this, I'm going to actually demonstrate you how you can check for the same, right? How many of you all know that there are two layers basically? One is the front end layer and one is the back end layer. Everyone is clear with this concept, right? At least, what is a front end layer? In a website, what is a front end layer? What the user sees, right? What is front end built of? Sorry? HTML, CSS, JavaScript, right? That's the basics of what front end is built of, right? This is what we are talking of web applications. But .app, which when zipped gets into something called as .apk or .ipa. So essentially your source code, your mobile application that you install on your mobile device is actually the source code that you have. And I'm not lying onto this. You can actually see the source code. How? Let us take an example. So over here, I have this file called as dvia-v2.ipa. Okay, this is an Apple specific file. It's an Apple code file called as .ipa. If you double click this file, okay, it's going to get installed. Obviously, how many of y'all have played Subway Surfers on your phone? A lot of y'all, right? How many of y'all remember the application Lucky Patcher? A few of them. Okay. The rest, do you know what Lucky Patcher was? Do you know in Subway Surfer if you install a modded application, mods pata hai? You know mods, everyone knows mods, right? You remember you mod that application to have unlimited lives in your Subway Surfers or unlimited coins in your Subway Surfer, or on your Candy Crush application unlimited lives. How those things happened? Lucky Patcher did a patching mechanism. How that patching mechanism happened? It was because your source code lies onto your mobile device. Each source code, whether it is WhatsApp, Telegram, everything. The source code of the application lies onto your mobile device, and here is where you find the source code. But the problem is the source code is not easily visible, okay? So if you go over here and let's say you are going on to this home and you are going on to this file. If you see these files are basically encrypted files with iOS based application. The problem is that these files gets encrypted, okay? That does not mean that you cannot extract sensitive information from it. You can definitely extract it, but we are going to have a look how at a later stage. But for now, remember that your files gets encrypted over here, okay? So this is the first part that we talked about. That is the source code part, okay? Source code part is the first part that we talked about. There are two more parts that we need to talk about. One is this layer, the second number, okay? This basically means that you have a local authentication, you have some local files, and you have a local database. So your Lucky Patcher used to patch your Candy Crush application. How? Your Candy Crush application basically stores number of lives into a local database on your device. Okay, so on your device you have databases like SQL, you have databases files like SQLite, you have files like info.plist, you have other plist files. There are various different files that are present. So these files basically store sensitive information such as number of lives. Okay, your number of lives is time dependent. So every time your system clock increases by 30 minutes, you get an added on life, right? That's how Candy Crush Live is working, right? So what happens is Lucky Patcher, what it does is it modifies these files. These files are nothing but your local files that are used. Your local authentication is nothing but the touch ID, the face ID, the touch ID and the face ID that you use to unlock your device. That's what local authentication is, okay? And then finally you have a third layer, that is a web server and a database server, which is present inside your backend, okay? So whenever you are testing an iOS file, these are the three things that you need to test for. Okay, at this stage of yours, it is very beginner that you might not even understand this, but just keep in mind, because this is something that is a very niche field and not a lot many pen testers in India specifically know about all of these things. Okay, so this is something that is very, very niche. So we have like 3 test cases that we usually perform. One is called a source code review. That is basically reviewing the code that we talked about. That is over here, the source code review. The second one is the static analysis, which basically means that we'll be reviewing the files, the local databases, etc. And the third one is dynamic analysis, which means that we'll be playing with some of the requests, which we might be able to do it today or not, or we'll see. So static analysis will be playing out and we'll be doing a patching of Candy Crush application, similar to Candy Crush application. We'll be patching something. So this was about introduction. As I mentioned before, if you decompile an IPA file, okay, this is something that you are going to get. So you have first and foremost that you are going to get is the info.plist file, which you can find over here. Right. So this is the info.plist file that you can find. What is present in this particular file is your permissions. Okay. So whenever you open an app, the application is going to ask you for certain permissions. Permissions like accessing your contacts, accessing your weather information, accessing your call logs, etc. All of these permissions, the application gets to know from here. Okay, so if you see over here, there is something called as oops. Yeah, if you see over here, there's something called as NS camera usage description, which basically means that the application is going to access your camera. So this is something that you can learn, that which application accesses what. So if the application accesses camera, it is present over here that the application is going to access your camera. The application is also going to access your Face ID. So that also is mentioned over here that the application is going to access your Face ID. So that is what is present inside a file called as info.plist. There are multiple folders. Let's not go much into detail of these folders, but yeah, there are multiple folders that are present as well. Jailbreaking. How many of you all know about jailbreaking? All right, few of you all. How many of you all know about rooting an Android device? Okay. So in your Android device, and okay, how many of you all know what is a root terminal in Linux? Most of you all know what is a root terminal in Linux, right? You write sudo su and you get a list of higher privileged user, right? Ever wondered if a similar, okay, what is your Android running onto? Which operating system your Android runs? Which operating system does your Android runs on? Linux, right? So ever wondered what if you can do sudo su in your Android operating system? Can you do it? Can you do it?
Yes.
Sorry?
You should be able to.
No. The answer is no. You cannot do sudo su onto your Android operating system until and unless you don't jailbreak it. Sorry, you don't root it. Okay. So for Android operating system, there's something called as rooting, which basically means that you're patching your OS system, you're patching your kernel to get the root access of your Android system. Okay, the iOS equivalent to rooting is called as jailbreaking. Okay, so jailbreaking basically means that you're going to get the root access of your system. There are multiple jailbreaks that are available, with the last working jailbreak is for iOS 18. You can find jailbreaks online. Jailbreaking will void your phone's warranty, so don't do it until and unless it is extremely required. But jailbreaking is a concept using which you can get the root access of your system. For those who have heard about pen testing, do you guys have heard about OWASP? Okay, for those who haven't heard about OWASP, OWASP is basically a security project, which basically means that in the security project, there are a list of vulnerabilities that you can find inside devices, inside web applications, inside mobile applications, etc. For now, we have OWASP Mobile Top 10, which means that these are list of top 10 vulnerabilities that you can find inside a mobile application, right? Let's skip that part. Now, coming to another part that is called as Mac OS pen testing. Okay, how many of y'all own a Mac OS right now? All right, 1, 2, 3 of y'all. Okay, 4 of y'all, right? So for those who do not own a Mac OS, does this feel irrelevant to you? It is not irrelevant. The reason being because even if you don't own a Mac OS, someday later you might own one, or you might be working for companies that might give you a Mac OS system, right? And at that point of time, they might expect you to test certain Mac OS based applications, right? So what we are doing is we are learning a niche field. Even if you don't own a Mac OS system, we are trying to learn how Mac OS exactly works, how Mac OS file structure works, and how things are there inside Mac OS. Okay. So again, inside a Mac OS system, you get a source code. Okay. This source code, when compiled, okay, when the source code is compiled, when a Java code is compiled, you get a .java file. When a source code in Mac OS is compiled, you get a .app file, okay, a .app file. This .app file, when zipped up, okay, when it is zipped up, it gets converted to something called as a DMG file, okay. So whenever you download Mac OS application from online, DMG files get downloaded, and these files are there to get installed inside your Mac OS system. So you get a DMG file. This DMG file is published to the App Store, and it is installed on your Mac OS machine. Once it is installed on your Mac OS machine, again, the same thing. You have local authentication, you have local files, and you have local databases, right? And then via the APIs, these get connected to web servers and your database server that is there at the backend, right? Moving on. The key differences between iOS based applications and Mac OS based applications is this. This is pretty much into detail, but just to give you a reference, we have something called as keychain, we have something called as plist files, we have something called as SQLite files and core data that we are going to take a look. Okay, besides that, these are like some of the tools that we can use. Some of them are Hopper, some of them are called as Hopper, Ghidra, OTool, ClassDump, Frida, LLDB, etc. So these are like some of the tools that can be used in order to perform various types of testing. Okay. Moving on. let's have a small recap of the application bundle file structure. Okay, so whenever you decompile a DMG file, okay, you get certain types of folders present over here. One is called as the info.plist folder, which again, similar to the iOS one, you have all of the permissions that are listed down over there. You have hard-coded API keys listed down over there. You have hard-coded secrets that are listed down over there. Then you have something called as code signature that has signature files that are basically signature files. You have something called as a macOS folder that contains the actual binary. You have various type of resources, let's say images, videos, fonts that are available, and then you have various package infos as well that is present. Let's take a look of it. So over here with me, I have this file called as DVMA, that is Damn Vulnerable macOS Application. You can download this file from my GitHub repo, which is present over here. So DVMA is a file that is basically a vulnerable macOS application file, which is a practice playground for you to play around with macOS vulnerabilities. Okay, so you have various types of vulnerabilities that are included over here, and you can play around with them. So I have this particular file that is called as DVMA. Yeah. Okay, so if you right click onto this and if you click on show package contents, you have a folder called as contents, over which you have something called as info.plist file, where, as I mentioned, it shows that which permissions it is being used. For example, over here, the permissions that are used are camera, location, microphone, and photo library. So these are like the various different permissions that are used within this particular application. Besides that, you have something called as macOS, wherein the actual binaries are being run over here. So there are like 3 binaries that are present over here. Binaries basically means that these are the actual codes that are written. Okay, so if I just go over here and if I ls, oops, yeah, so this is basically the entire code that is written over here. So this is the entire lines of code that is written. As I mentioned, the code lines are basically encrypted, so you cannot read the exact source code, but there are codes that are present over here. Right, besides that, we have various different types of resources. For example, there's this resource called as Google Service Info.plist. Any Flutter developer in the house? Flutter Firebase developer? Anyone heard of what Flutter Firebase is? Right? Okay. But anyone who has developed in Flutter or might have used Firebase a little? Firebase. Okay. Okay. So Flutter and Firebase is basically an operating source code, or you can say it's basically a language that Google has created. Flutter is basically an SDK that Google has created, a software development toolkit, which basically helps you to code inside macOS, Android, iOS, web applications, etc., all of the operating systems with just one code base, and you can run that code in any operating system you want. So if you want to create like real-time applications in Flutter, you just have to write the code once, and that particular code can run on all of the operating systems that are available right now. So it can run on Mac OS, it can run on iOS, it can run on Android, etc. With Flutter, there's a complementary thing that comes up that is called as Firebase. What Firebase actually does is, it is basically acting as a cloud backend system for you, which basically means that it has authentication methods, it has databases, it has NoSQL data, file storage. You can deploy your AI/ML models over there. It has storage for your images, etc. So there are multiple options or multiple features that Firebase provides you. When you include a Firebase and a Firebase database, there's something called as Google Services info.plist file that gets created, and this basically has information of all of the Firebase details. So for example, over here, if you can see, there is an API key that is being stored over here. So as I mentioned, there are hard-coded API keys that are present. So that is stored over here. You have something called as the database URL. So this is basically the database URL where it is stored. You have the storage bucket URL. So you can see the storage bucket URL is being leaked, etc. Right? So these are all of the different things that it stores. Okay, then you have certificates and you have icons. So if you double click onto this, this is basically the application icons that my particular application is running. So this is where your okay, this is where your app, once you click on show package contents. Okay, this okay, no mobile application developer is there in the house, right? Anyone into mobile application development by any chance? You all, two of you all, okay. How does the mobile application gets pushed to the Play Store and App Store? Any idea? Have you pushed it? No? Okay. Have you created, which language do you create in? Sorry? Flutter. Okay, cool. So you haven't pushed it. Did you create a production app of it, or it's just, right, production app, and you created an APK of it and you just gave that APK to everyone? That's it, right? Okay, understood. All right. So if you want to push your applications to Play Store and App Store, you first need to sign it, right? You need to sign it. What is signing? Signing basically means that, okay, so remember when I told you that your source code is actually present where? On your mobile device, right? Which means that anyone can tamper with that source code, right? Which basically means that if I'm a hacker, I can download WhatsApp, I can modify WhatsApp, and I can push WhatsApp back to Play Store, and everyone else will have my version of WhatsApp, which means that I can essentially read everyone's messages, right? But that doesn't happen. Why? Because there's a mechanism called as code signing. Code signing basically means that if WhatsApp is developed by Meta, Meta will have their signatures, okay? And if you tamper the application, you need to sign the application. If the signature of your tampered application and the signatures of Meta, if they do not match, okay, if they do not match, your application is going to get rejected, stating that you have hacked that application and Play Store is never going to upload it, okay? So every time you upload your application, you require a signature. This signature is called as code signing, okay? It's called as code signing in iOS based or Mac OS based application. Code signing basically ensures that the application has the integrity and the authenticity of its actual developer. With code signing, each application that is code signed has a developer reference attached to it, okay? So each time you tamper the application, you need to code sign with your own signature that is present, that can be present over here, right? So that is what code signing and entitlements means. There's another term in macOS that is called as system integrity protection. System integrity protection is an added on feature. It's a security feature in your Mac OS application that when enabled does not allow you to reach its kernel. How many of you all know what is a kernel? Very few. All right, operating systems, सबको पता है क्या होता है? How many of you all have learned operating systems in college? बाकी लोग को subject, for the others the subject did not appear.
Second year.
Oh, it's in second year. Okay. All right. So your operating system is called the heart of a computer or of a laptop, right? But it's not the heart. It's just a cave of that heart. The heart is the kernel that is present inside the operating system. Kernel is something that is the one that executes a lot of stuff, okay? It is the layer between your software and your hardware, okay? So your hardware, your keyboard, mouse, everything, and your software is the applications and everything. Kernel sits in the middle. It is the one that helps you out to perform hardware stuff to software and software stuff to hardware, okay? So that is the one. Now kernel, when the kernel gets, if you get the access of the kernel, that basically means that you get the access of your entire system, entire computer, okay? So to protect kernel is a challenging and the most difficult task, and as Apple claims that Apple loves privacy, okay? So they have come up with this feature called as system integrity protection, which basically means that when enabled, you cannot access your kernel, okay? Neither any of your application can access your kernel, okay? This system integrity protection can be disabled at your own risk, okay? For now, for me, if you want to check whether my SIP is enabled or not, what you can do is you can just go to your terminal and write CSR util status and CSR util status, and it is going to tell you that system integrity protection status is disabled, which means that I currently have access to all of my kernel level APIs and kernel level operating system, right? This is something that I have disabled it for me. Why? Because I want to hack my Mac OS based applications, and to hack our Mac OS based applications, we require a lot of tools. These tools basically play around with your kernel level APIs, with your system level APIs, okay? For those who do not know, who haven't read about operating system, your operating system also has APIs, just like your web application. Your operating system also has APIs. The simple thing that you do, that is right click and you create a folder. That creation of folder also has an API that goes to the kernel, that goes to the kernel, and the kernel executes that, okay? So each and every step that you do in your operating system, each step is associated with a particular API, okay? So over here we need to play with those APIs. In order to play with those APIs, we require system integrity protection to be disabled, and that's what we have done. We have disabled it, okay? So that is SIP. All right, before we begin, Mac OS and Windows based desktop application testing also has OWASP top 10. I'm not going to go much into details of OWASP top 10 for this, okay? You guys can later check it out whenever you guys want to, but just an information from my end that OWASP top 10 is present for desktop based applications, which basically means that desktop related vulnerabilities, top 10 vulnerabilities of desktop related applications are stored over here. That's OWASP desktop top 10. All right, question, why Mac OS testing? Why should I be doing a Mac OS testing? Okay, what things will I achieve from doing a Mac OS testing? यहाँ पे web application testing, I'm still learning web application testing. Why should I go ahead and why this talk? That's a question that might hit you right now. Why am I sitting after lunch? I should be sleeping, right? That might be a question that might be hitting you right now. Mac OS testing Why? The reasons are over here. First and foremost thing, I don't know how many of you all know about this, but Mac OS, iOS, Apple Watch OS, okay, your iPad OS, okay, all of them have a shared environment, right? Apple is known for its shared environment, which basically means that if I'm taking a call on my iPhone and if I want to switch it over to my Mac OS, I can do it with a click of a button, right? If I am wearing an Apple Watch and I want that to get moved to my Mac OS, I can do it with a click of a button, right? Why? Because these are like shared environments that are present that Apple has given us, right? But with shared environments comes great responsibility, okay? So shared code base with iOS provides a catalyst in performing both iOS and Mac OS testing. For example, if I have, let's say, an iOS-based WhatsApp application, I can try to use that same WhatsApp application in my Mac OS application, in my Mac OS as well, okay? And anyone knows how iOS applications are created? Which language does it use? Any idea? No, Kotlin is used for Android. For iOS, Swift. Swift and Objective-C is the programming language that is used for iOS-based applications, okay? What developers do is, they use Swift and Objective-C and they create a same code base, okay? And with that code base, they also create Mac OS applications as well, right? So your Objective-C and Swift UI, you have a single code base for your iOS and Mac OS both, okay? So one single code base for both of them. Then you have privilege escalation risks that are present. So every application has some of the other misconfigurations that can be present. We are going to have a look at some of them in a couple of minutes. You have reverse engineering threats, you have insecure data storage, and you have insecure network securities, which means that whatever we saw, insecure code layers and everything, all of them has some of the other risks that are present, and that's the reason why you should be doing macOS testing. The last thing before we move ahead to the practical is sandboxing. Any idea what sandbox is? How does an antivirus operate? Any idea? What is an antivirus? Itna pata hoga, no? What is an antivirus? Virus protections. How do they operate? How does antivirus know whether it's a virus or not? We as humans cannot know. How does that know? Sorry? Testing the virus. What does it test for? And why in a control environment? Right. So it does not infiltrate our operating system, right? So what does it do? What's a control environment? Where does that control environment get created? Is that like their own lab that they create, or is that their cloud PC that they create? Where? Right. So the answer to all of these questions is sandboxing. What is sandboxing? To give you a very simple answer, whenever there is a virus that gets installed, or whenever any file gets installed onto any of your machine that has an antivirus installed into it, what the antivirus does is it basically captures that file, okay? It sends to a space, a virtual memory space that is specifically confined to testing. It tests that application, it installs that application into that virtual memory. It tests whether it is performing some ill effects, whether it's performing some evil behavior or not. There are a lot of signatures that it checks onto. And if all of those things are perfect, okay, then it marks that the file is not harmful. But if one of that check fails, it marks that the file is harmful, okay? That virtual memory that we talked about is nothing but sandboxing, okay? It's nothing but sandboxing. You can consider sandboxing as a container, just like a Docker container. If you heard of the word Docker, a container into which your application is installed, okay? Now, Apple loves privacy, and it's their tagline that Apple loves privacy, right? So what Apple came up with the idea is, whether it be your iPhone, your iPad, your Mac OS, your Watch OS, anything, for each application, it has started creating containers, okay? So that one application cannot interfere with other applications' data until and unless you are not the root user. If you are the root user, you can access everyone's data. But if you are not the root user, one application can never interfere into the other application, okay? So one application, WhatsApp, has its own sandbox. The other application has its own sandbox, okay? So two applications cannot interfere with each other. That is what sandboxing is all about. All right, so we are going to get started with source code review and static analysis, okay? And we are then going to move on to some of the important parts. If you want to install DVMA, as I mentioned, DVMA is a purposefully designed vulnerable Mac OS application. If you want to install it, you can install it, okay? You might not be able to run it, but you can definitely install it onto your Windows machine as well. And you can, if you want, you can follow along. If you don't want, just relax, sit back, watch what I'm doing, try to learn something, and that should be enough, right? So this is what DVMA looks like, okay? It's a simple desktop application, desktop Mac OS based application. You can see this is the desktop application that is here, and I'm running onto it. It is specifically developed to explore and learn common security vulnerabilities in Mac OS based applications. If you click onto these three buttons, right, I have listed around like 15 to 20 different vulnerabilities that you can find, starting from excessive permissions granted, okay? With each vulnerability, you have a description that is present over here, which helps you out figure what we are actually looking out for here, what is the actual issue. You have a small OWASP mapping. OWASP mapping, we have already talked about what it is. So you can skip that for now if you want to. And then you have something called as hint. Hint is where it's going to help you out to check what other things or how you can find these particular vulnerabilities, okay? What you can do is, I'll be showing you about, let's say, 2 or 3 of them, okay? The rest you can practice at home if you want to. But I'll be showing you 2 or 3 that is of the utmost interest and that awakens you, because I can see a lot of you are sleeping. So the one that awakens you, that makes this session much more interesting, I'm going to show you that. So let's skip the boring stuff, okay? Let me show you something called as this one, okay? So this is something called as insecure Touch ID implementation. All right, I'm not sure how many of you all know this, but each Mac OS basically has Touch ID, okay? It's similar to what? It's similar to your iOS device. If you click onto this, okay, there's a pop-up that comes up that says authenticate with Touch ID, okay? So if I just give my Touch ID over here, it's going to say authentication is successful, which means that I have successfully authenticated to the application, right? Now you may see the same screen, but if I click on cancel, it is going to say authentication failed, and it says, what does it say? Authentication cancelled, okay? Authentication failed. Why? Because authentication was cancelled by the user, which means that if I click and if I give my right finger, it is going to say authentication successful. And if I click and if I just cancel it, it's going to say authentication failed, right? We need to hack this, okay? We are going to hack this. How are we going to hack this? In the next 5 minutes, what I'm going to do is, I'm going to authenticate in front of you, okay? And I'm going to click on the cancel button. Remember this thing. When I click on cancel, it says authentication failed, okay? But as soon as I click on the cancelled button, it is going to say authentication successful. Okay, so we are going to hack this up. How is something that I would keep it for a later stage. Okay, but for now, let me just do some magic stuff. All right. Now I am again trying to authenticate. Okay, and this time I'm going to click on the cancel button, and it said authentication successful instead of the default authentication failed. Okay, how many of y'all want to know how did this happen? Okay, everyone, right? Okay, cool. So over here, what we actually did was we used something called as Frida. Okay, we used a tool called as Frida. I'm not sure how many of y'all were paying attention, but onto one of the slides, I did tell you that there's a tool that we can use that is called as Frida. Okay, let us understand what Frida is. Okay, so I'm going to search for Frida. Maybe search it using GitHub, right? So this is a tool that is available. Oops, we don't want to go into releases. Yeah, so this is a dynamic instrumentation toolkit for reverse engineers, developers, and security professionals or security researchers. Okay, what does Frida do? Remember, I told you that kernel, right? Your kernel is the one that is talking with the APIs. Okay, the APIs, what are these APIs that the kernel is talking with? Okay, so every time you hit that authentication method, there's an API that comes from here and goes to the kernel and states that, hey kernel, this particular application is using that particular API, okay, and this particular application wants to authenticate. Can you ask the user to touch the touch ID and verify whether the user is real or not? Okay, the kernel then displays that dialog box stating that, hey, authenticate, right? As soon as you authenticate, the kernel sends a positive response that, hey, the user was successfully authenticated. If the kernel, if we hit the cancel button, the kernel sends a response that, hey, the kernel has been, the user has cancelled the thing, so we are cancelling it. Okay, so the error code is cancellation. Here comes Frida. The kernel sends a cancellation message, but what Frida does is, Frida basically tells the application that the kernel, instead of sending the cancelled message, has sent that the user has successfully authenticated. And I'm not bluffing this up, okay? I'll prove that this is how it works. Okay, in order for me to do that, how did this happen is, there is a script that I run. So if you go over here, there's a script that is running over here. You can see the name. What is the name of the script? touchid-bypass.js. JS is a JavaScript that I'm running. Let's read the files. Let's read the contents of this. Okay, so right, if you see over here, okay, if you see over here, there's just one statement that is return callback true, comma null. Return callback true, comma null, which basically means that whatever is the response from the kernel, you should always return true. Okay, you should always return true. So what I did was I was running my script in the background, okay, which is over here, trying to bypass Touch ID. I was running the script and then I went over here and I hit the cancel button, and it always shows authentication successful. If I exit from the script, okay, and if I hit the cancel button, it's going to say authentication failed. Why? Because now my kernel response is not getting modified. Okay, now my kernel response is not getting modified. But here is the problem. Remember when I spoke about SIP? What is SIP? System Integrity Protection. When I spoke about SIP, System Integrity Protection, I told you that for tools to run, for us to run with kernel, okay, for us to run stuff with kernel, we need to modify SIP. Okay, we need to modify SIP. Now, on a victim's Mac OS, you cannot modify the SIP. Why? Because you don't know his password, right? And sometimes what the application does is, okay, so I have a similar stuff over here. What the application does is, the application won't allow you to run that app if the SIP is disabled. For my computer system, the SIP was disabled. Okay, for my computer system, the SIP was disabled. So this particular application says SIP is disabled and it's showing a warning sign. But for some apps, it won't allow you to run it. Okay. So in this case as well, you need to bypass SIP. Okay. So first you need to bypass SIP, which you can do in a similar manner. Okay. So instead of Touch ID bypass, I can run SIP bypass.js. Okay. Now, see over here that SIP is disabled. Now, as soon as I again open it back on, it shows that SIP is enabled. How this happened is again similar. We used a script, right? We used a script which basically uses POSIX_spawn. Okay. So even if I go to the terminal, yes, it says POSIX_spawn hook enabled. Okay. And it says that CSR util is running. CSR util basically tells us, okay, so if you remember, we used CSR util status and it says System Integrity Protection status disabled. So which basically means that it is using CSR util and it has replaced the word disabled to enabled, and that's how it went back to our application, and it said that your application has SIP as enabled. Okay, so that's a second bypass that we have taken into consideration. All right. Okay. Anyone got any questions? I know most of the things might just go above the head, but still, if you guys have any questions, you can ask me right now. There are more such exercises that you guys can perform. I don't want to perform all of them over here because one, it might be a bit overwhelmed for you guys because it's something that is a new concept. So I don't want a lot of things to get above your head. Second, you guys might be a bit beginners, so I would not want you to load yourself with a lot of stuff, right? So there are different things that are available, but what you guys can definitely do is you guys can visit my GitHub, okay, download this DVMA, okay. There are Mac OS based applications. There are various Mac OS based ISO files that are available online as well. using which you can save it into your VirtualBox and run a Mac OS environment, right? And yeah, that's it for the session. If you guys want to connect with me, the left hand side, the bigger QR code has all of my socials listed. You guys can connect with me onto any of my social. If you want to save this presentation, the right side QR code is there to save the presentation. So that's it, guys. Thank you very much for being a lovely audience. If you guys have any questions, you can ask me right now.
So that every application on macOS is sandbox.
Right.
So does macOS not have the concept of DLLs at all?
DLLs, no. So DLLs only work inside Windows. They are not there in macOS. So macOS,
Won't the file size will be very big in macOS?
sorry?
Won't the file size will be very big in macOS?
File size.
Yeah, because you're not getting any.
But instead of, so what essentially is macOS? What operating system does it run? What is the macOS operating system that it has? Essentially, it is a Linux. It is a Linux terminal that is there below it. What is Kali? Kali is what? It's a Linux, but it's a flavor of Linux, right? macOS is nothing but consider it as a Linux machine, and it's a flavor of Linux. That's it. Okay, so how macOS apps runs is they use threads. Okay, so one application is broken down into smaller threads, and that's how it runs. It does not have any concept of DLL. That's it. Okay, any other questions? All right, thank you guys. Anyone wants to scan this, or can I take it off? Okay, perfect. Thank you.